Alright guys, welcome to today's show. I have been locked out from my Linux machine and I'm trying to break back in. I have managed to acquire the following password hash, but it's encrypted in a one-way kind of way. So our work of today is trying to crack that password by trying all different combinations in order to be able to get local access to the machine. So let's begin. We need to do some password cracking. So let's shut this down for now. Alright, so how do we do that? First off, let's save this right here. Well, we need to, first of all, we need to grab some word lists that we can use as a basis. So if we just Google for English dictionary, ASCII text file or something. So let's see. There should be some American university or something which has something like this. The Carnegie Mellon University. That's probably it. CMU Dict. Is this the correct one? Pronouncing dictionary. Oh, why does it always link to this site? It's so difficult to download. Let's check for something else. Project Gutenberg. Also GitHub. So let's see, UK, US dicts. And we don't see the file size here either. Words contains all words, okay, let's do that. But we can't download one file, can we? View raw. This link should be able to use, because this is probably what we need. It looks great. So let's see here. So let's download this through wget. And there seems to be a lot of weird stuff in the beginning here, but let's not worry too much about that. It's also both in caps and not in caps. I think we want to make everything lowercase to begin with. So we can run tr, text replace, and we want to change, let's see, from upper to lower. The syntax is a little bit weird. And we go from words to words 2. Alright, now everything is lowercase. That's nice. So let's create some bash script for hashing, because we can hash just by doing this. So if we say something, if we want to try cat, for instance, then we can pipe this to OpenSSL MD5, because MD5 is the kind of hash that this is. You see, it looks the same as ours. Well, not the same, but same format, same number of characters and same kinds of characters. So let's use this to create some bash script which goes through an input file, and yeah, you get what I mean. So let's see here. Let's call it crack.sh. Start with a shebang. Right, so let's see here. If let's see if I remember the syntax. So we want to take 2 arguments: the file with all the words and the hash we want to compare it to, right? Alright, we do this. So if the second argument is 0, in that case we echo some usage, and we want to have a word list and hash. And then we exit. Okay, so what do we want to do here? Well, we want to loop through the file. So for I in cat in the file, and for each and every one of them we want to run some function, right? So let's call it verify hash or test hash, and we provide the current word, and we provide the hash we want to compare it to. So that's 2. Something like this. Alright, so let's create this function. So test hash is a function, and if we don't have an second argument, in that case we just want to return 0. Otherwise we set some local variables. So let's say we have the word, which is first argument, and we have some hash, which is the second. Maybe we can call this original hash.
And let's define these local variables. Like so. And we don't only want to test the word at hand. We want to, because as I mentioned before, passwords are rarely like cat for a user in a server, because the server has some length requirements, often 8 characters, and it has some. It requires that there are some numbers and there are some small letters and big letters and stuff like that. And most people, let's say if they have their regular password like orange in from the web interface, most people just want to pass that security requirement. They don't worry too much about it. So they take the regular password, they change maybe the first or the last character to uppercase, and they add either 1 or 1, 2 or 1, 2, 3, or perhaps like this. So we need to take that into account as well. Which means we need to have some function which replaces the first character in a word with the uppercase version of it. So let's say we have word 2, which is like that. So word 2 is equal to, and then we run some function. Let's call it I don't know, to upper, I don't know. And we provide the word. And what about the numbers? So we want to run some, let's see. Let's say we have we have 1, we have 1, 2, and 1, 2, 3. We have 9, 9, 8, 9, 8, 7. These are the most common ones. So for each and every one of these combinations, we want to run the verify hash function on that. No, not on that. We need to create the, let's call this word 3, which is word 2 with the number afterwards. So we run it like this. And we need to provide the original hash as well. And this we need to do once for the word to, but also once for the regular word, which does not have the capital first letter modified. So that is word without the to. And we also want to, first and foremost, we want to verify the original thing as well, which is just word. So now I think we have all the different combinations. But how do we replace the first character? Let's see here. If we create some variable tmp, and let's say we have the word orange, and we want to make it orange. How do we do that? Well, first we need to grab the first character, right? So let's say we have character, and we can grab that by doing this construction. And let's see if I remember how to use these numbers. I think we want to grab one character at index 0. I think that's how it's done. Nope, that sure wasn't. Let's change this to index 0, one character. Okay, there it is. We grab the O. And we can transform this O to uppercase the same way that we did before with the tr command. So this time we go from lowercase to uppercase, like so. And let's put this into a variable. Alright, so how do we replace it? Well, let's echo our original, and then we can do some sed magic. So we want to replace, let's see, start of the line, and then we have one character, A to Z. And this we want to replace with character 2. That's it, I guess. No. We need to use the double quotes here. Okay, that's nice. Alright, so now we know how this is done. Now we can implement it. So let's see. So what did we call that function? To upper. So to upper is a function. We want to make sure that we have an argument. And if we don't, what are we going to do? Let's echo the original one, because we can't return a string, and then we return a 1 to indicate that something is weird. But why echo it when it's not there? Let's just return 1. We can't do much. Can't really invent something here. Hopefully it will not happen, right? Okay, so let's create some local variables, same way as before. So we need a character. We need a character 2. What else do we need? We need a temporary thing. We need the final thing. It's called direct. And you can probably do this in one line, but I'm not sure if it's separating by a space. I think it is, or by a comma, so I don't want to mess with that right now. Alright, so first off, TMP is going to be our word, right? Our character is going to be TMP. Let's see, what was the order? Zero, one. So we want to grab index 0 and one character. And our modified character is, so let's see how we want to do this. We want to run text replace and go from lower to upper. And we want to provide our character. And when we have the uppercase character, we can provide our return string. And what we run is sed, and we want to, let's see, we want to sed the beginning of string A to Z. I want to change it to the character 2. Provide let's see here. We need to provide the original thing, right? And then we can return this by echoing this return thing and returning 0, like so. Alright. And now we just need to create this verify hash function, which shouldn't be too difficult. So verify hash if we need 2 arguments, and if we don't succeed, we can just return 1. And what do we have here? So we have the word and we have the original hash. And we're going to have a hash, which is a new one. We're going to create one of, So word is the first, right? Is it? Verify hash, word original hash, yes. And we create the hash by running printf on our word. Pipe this to OpenSSL MD5, but how did the output look? Let's see. We get this weird thing here. So I guess we need to cut the second word. Yeah. It's annoying when they print output in that way. So we cut based on spaces and we take the second one. Okay, so now we have a hash and we have an original hash. Now we can compare the two. So if if hash is equal to original hash, that means that we are done. We have found the thing. So let's make this shown. So let's print like this. Something like this. We have the original hash and we have the word. Something like this. And maybe we can print this to standard error just to make sure that we don't, that we can grab it. And then we can exit the entire program. Otherwise, we just return 2, let's say. Okay, something like this. So, what was I thinking? There was something else. Right, we're gonna try a whole lot of passwords, right? So maybe we need some kind of indicator how far we are in the process. So let's see here. So before we begin here, let's say we have some variable which is the number of lines of the input file. So let's just cat the thing. Like so. Let's call this S lines for the string. And then we have a lines, which is an integer. So we can do let lines is equal to this line. It's not really necessary, but just an OCD of mine. Okay, so now we have the number of lines. Let's also say that we have a modulus. And we'll let the modulus be the lines divided by 100. So every time we have gone 100th, we will do something, print something on the screen or something. So let's see here. We need to export these, I guess. Lines and mod. So when we run test hash, and we have finished with the word, then we can do lines minus minus, and if lines modulus, so if we have gone 100th through the file, in that case we just want to print a dot, let's say. So we have some kind of indicator. Okay, I think this is going to work. Maybe I have some typo somewhere, but I think it's going to work. So let's say we have some test file. Let's see how the end looks. Let's take 50 of these from the end of the file. Let's call it tests.txt. So now we have a test file which looks something like this. And then we throw in something like orange. And let's create the hash. So let's say orange 987 or something. And now we try this on the small file, because it's easier to debug a small file than a huge file with 300,000 or whatever. So let's try this out. So the word list is called test.txt, and the hash is this. Division by 0. Huh, it did find it though. Look, it worked on the first try. Isn't that pretty cool, actually? Well, it's got some errors, so the only thing that didn't work is our indicator. So division by 0, it did not pass these variables, even though I exported them. That's annoying. Well, I guess we need to pass it as R arguments. Or is there a global command? No. Maybe we need to define them before we create the function. Could that be it? It's worth a try, I guess. So if we put them up here instead, then we export lines mod. Alright, so let's run this again. Nope, still the same problem. We could pass it as an argument, but we run this function a lot of times. And how would we return the value? It becomes very difficult. Maybe we don't need some indicator, do we? We could try one thing though. So 1, 2, 3, 4, 5. What if we were to put it inside of the loop? Would that work? I'm not sure. But maybe it's worth a try. Nope. Still problemo. It's really annoying that it behaves like this, isn't it? If any of you have a solution for this kind of stuff, please tell me. But for now, let's just don't use it. Hopefully my machine is fast, right? Okay, one last try with the test file. Looks nice. Alright, so let's run it with the big file. So let's see, it's this one. So we run crack against word 2 and we provide this hash. Alright, fingers crossed. But this will be all for today. If you like this episode, please like and subscribe, and we will continue this project in a later episode.
Thanks for watching. Thanks for today.